problem was done in class from all this packet. So now if you need us to do all of them, we will do all of them. Okay, that's fine. Okay. Good, so the first one, it's asking us to graph f of x or g of x as 6 to negative x. So the base function here is, the base function is
6.
There is no base function of 6. We never graphed a function that is 6. We graphed the absolute value of x, we graphed exponentials, we graphed log. We never graphed a function that is 6. So it cannot be the base function. But we graphed a function that is 6 to the x. Yes, that we did. But a graph of a function that is 6, we did not. Agreed? Very good. So there is only one transformation here. What is the transformation? Yes, because I replace x by negative x, and I get a reflection with respect to the y-axis. Very good. Perfect. So now, how do I graph the function 6 to the x? Is it a function that is increasing on all its domain, or is it decreasing on all its domain? Perfect, because the base is great. There is no negative base. Because the base is, there are two possibilities for the base.
Number greater than 1.
Greater than 1, indeed. So the base can be between 0 and 1, in which the function will be decreasing, or when the base is greater than 1, the function is increasing. Where does a pure exponential function cross the y-axis? Always, if it's pure. Exactly. Excellent. 0, 1. And increasing, so this is 6 to the x. Awesome. What is the horizontal asymptote of this graph?
0.
Very good. Y equals 0 to the left. Perfect. Now we want to reflect this graph with respect to the y-axis. So here's what we do. I need a different color, sorry. What is the horizontal asymptote of this graph?
0.
Not 0, but y equals 0. Very good. So they want us to find domain. What is the domain of an exponential function? Is it friendly?
Yeah.
Perfect, which means all real numbers. Can anyone identify the range of this function?
0.
Indeed. So domain negative infinity to infinity and range 0 to infinity. Perfect. Awesome.
Do you want to graph both of them?
Yes.
Okay.
Please.
Okay.
Please.
Because I know on my laptop it doesn't always do.
Right.
Okay. Alright. Sure.
My pleasure. In number 2, we are given basically this is a of t. P 1 plus r over n and t. These two formulas will be given to you, but you have to remember what they represent. Because if we don't remember what they represent, then we're going to have difficulties with this. So what does the first formula represent? It represents the interest compounded n times, whatever. Semi, 4 times, 12 times, whatever. Yes, n times. What about the other one? Oh, awesome, thank you. Good, so now let's see what they want. Find the cumulative value of an investment of 25,000. So that's 25,000 P. 3 years, T equals 3. At an interest rate R 0.05. If the money is compounded semi-annually, what does that mean? N equals? Very good. If it is compounded quarterly, if it's compounded monthly, and continuously, there is no n. Very good. Because I have to use this formula 3 times, I recommend do this. Of course, you don't have to. You can use a different way, just plug it in twice, 3 times. That's fine. So in y equals, clear if you have anything else. And we put in 2,500. No, it's 25,000, sorry. In parentheses, I have 1 plus. Remember the percent. It cannot be in the percent. It has to be in a decimal number. Divided by x, because x will change from 2 to 4 to 12. Close the parenthesis, put the symbol for the power, and in parentheses we have 3x. 3 is t, and x is n. I'm creating this function only because I don't want to repeat the process 3 times. I want to go to second and table. Let me see if I have, yes, second and table. And I plug in 2, 4, and 12, and I get all the answers right away. So I have to go back to those answers because I need the cents as well. So 28,992.34, that's A of 2. $28,992.34. Then A of 4, scroll down. $29018.86. And A of 12, 29036.81. Now for the continuous compound interest, I don't have any choice. I have to go back to and it's just one calculation, get out of there. So, and we want 25,000 times E right here with natural log in parentheses. What do we have? 3 times 0.05. Close the parenthesis and press enter. 29045.86. So A of t continuously is 29045.86, or just A. For this one, it's okay if you just write A, but the variable is time. Any questions? Do we recognize this so far? Okay, perfect. So suppose you have 13,000 to invest. Which of the 2 rates would yield a larger amount in 2 years? So the next problem has t equals 2 years. And 0.09 compounded monthly with n equals 12. And, oh, sorry. And 0.0889 with continuously. Thank you. And the principal is 13,000. So I have to look at 2 possibilities, and these are 2 different situations. So A of 12, which is 13,000. 1 plus 0.09 divided by 12 raised to 12 multiplied by 2. I'm just replacing the numbers. Principal, interest rate, n equals 12, n times t. And the other one for continuously, so it's A equals 13,000 e to 0.0889 multiplied by 2. So again, like the previous example or the previous problem, all I did was I just copied. Okay, so here I have 13,000 and times, in parentheses, 1 plus 0.09 divided by 12, close the parenthesis and the power, and that's 12 times 2, which is 24, and close the parenthesis. And the other one is 13,000 times E raised to, in parentheses, 0.0889, I think it was. 889, yes, times 2. And close the parenthesis for the power. And for the first one, I get 1553.38. 1553.38. And the other one, 15529.62. All I have to do is make a decision. Is it the first one that I prefer, even if it's not a big difference, or it's the second one? And you just have to say, I prefer the first one, because we get more money. Any questions? Any questions on this?
Is it continuously or compound or monthly?
Was it monthly?
Monthly or
Compounded monthly, so it's 12.
okay, because you said the first one, and the first one's continuously.
9% compounded monthly, or 8.89 compounded continuously.
Okay.
Is there a mistake? If you may see something that I don't.
No, you're fine. You're fine.
Everything okay? Okay. Number 4, we're given a function f of x equals 565 times 1.026 raised to the x power. And they want us, so 1975 means x equals 0. What about 2002? Means x what? 2029 x what? And 2056 x what? So what is x for 2002?
27.
Good. For 29? And for 2056? Good. So I create another function again. Same function that you see, 556, go to y equals, clear, 565, sorry, in parentheses, 1.026, close the parenthesis, put the caret in parentheses, I have x, close the parenthesis, and go to second and table, and quickly plug in 0, 27, 54, and 81. So I will copy 565 million, then I will copy 1129, 2259, and 4518. So the answer is f of 0, 565, f of 27, 112 or 3, 0, f of 54, 2260, and f of 81, 4518. And they want us to draw a conclusion. And it appears that every 27 years what happens is the population appears to be doubling from 5 to 100, from 100, from 1,000 to, from 500 to 1,000, from 1,000 to 2, from 2,000 to 45. So roughly every 27 years it doubles. Okay, is that clear? Okay, here we're given, say it again.
Hold on a second. I think, yeah, I get it now. I get it. My brain's just a little slow.
That's okay.
Thank you.
So f of x equals 6.201.028 raised to the x power, and g of x 37.3 over 1.6.1 plus 6.1 e to negative 0.051x. So basically so far 4 problems took us like less than 10 minutes. Okay, not too bad. Okay, so here we're asked which function is better for 2006. So I see 2006, the answer should be close to 27.3. So whichever function gives me a closer number to 27.3, then I will choose. So now this is 2006, and x equals 0 is 1950. So what do I plug in these two functions? I need to plug in x equals, if x equals 0 is 1950, and we're interested in, yes, 56. Very good, awesome. So we have to plug in 56. From 1950 to 2006, 56. Go back to y equals, clear, and put in these two functions. Be very careful how you put them in. 6.2, parentheses, 1.028. Caret. I recommended parentheses. It may work without, but you know me already. Second function, 37.3. If you do not put parentheses around the denominator, you will not get the correct answer. So be very careful. 1 plus 6.1 times e. If you don't put parentheses here, with some calculators, you will not get the correct answer. So minus 0.051 x, close the parenthesis for the power, and then close the parenthesis for the denominator. Are we okay with this so far?
Yeah, hold on one second, I'm still writing.
Sure. Is this okay so far? So now I go to second and table and plug in again. What am I plugging in?
56.
Very good.
Where do you
I subtract from 2006, 1950. 1950 is x equals 0, so we are focusing on 2006.
I think we got
That's okay. So which of these two functions will you pick? The first or the second?
Second.
Correct, because it's the closest to 27. So then I will say g of x is a better model for 2006. So f of 56 is 29.108, and g of 56 is 27.615. Choose g of x, because it's the closest to 27.
I have a question.
Sure.
So on the table in my calculator, it just has like 6 numbers, and I don't know how to change it to like.
You have to change it to the table set, so go to second table set. Right, and no, that's fine. So you have it, so second and table. Just plug in the numbers. Just disregard that.
So like 0.
Yeah.
0.
Yeah.
Oh, okay.
So you press 0 and enter
Okay.
27 and sure,
Thank you.
my pleasure. Okay. So where was I? Okay, next problem. Number 6. Graph this, find the vertical asymptote, domain, and range. So we have g of x equals log x minus 6. I'm not saying I want to change anything, but I really never ever like to give a test on the final week of classes, because I want you to have it before the final week graded, but I'm not changing anything. Okay, so let's find the domain of this function. What do I have to write to find the domain? We did this with log equations. So we know how to find the domain of this. What do I have to write?
So is it like H and K or something?
No. What can I apply log to? What type of numbers can I apply log to? Log is not a friendly function. It's not defined everywhere. To only natural log or log. To which type of numbers? Any log. Natural log, log base 5, log base 15, log base 1/3. Any log. can be applied to only what type of numbers? Positive. So then x minus 6 has to be a number greater than 0, otherwise log of x minus 6 does not exist. So this is x greater than 6, so the domain is clearly 6 to infinity. What would be the range of any log function before I even graph it? Correct, because it's the inverse function of the exponential. The exponential is defined on all real numbers and has range 0 to infinity. Log is the other way around. Defined on 0 to infinity, returns everything. Awesome. I don't even have to graph it, right? So I know the range will be negative infinity to infinity. Awesome. So now please let us know what a base function is. Not the base of log, but what is the base function? The base function is, that is a linear function. But the base function here is not a linear function. If I say the absolute value of x, what would you say? X minus 5. The absolute value of x minus 5, which is the base function. If I say the absolute value of x minus 5. Awesome. Now I say log of x minus 6. Exactly. Indeed. We are shifting log of x somewhere. Where? That's only one transformation here.
So you want us to find the base on the test too?
Yes, you have to present what function was used.
Okay.
Or the basic function. Yeah. So, like we did all the time with transformations. Correct.
Okay.
So where am I shifting this? You shouldn't be thinking because we determined the domain.
So where is this?
Exactly. That's why the domain is 6 to infinity, right?
Mm-hmm.
It must be, correct. So this is right 6. Perfect. Awesome. Well done. So now I have to remember how to graph log x. Is it increasing? Is it decreasing? Why? Because there is no such thing. Because the base is greater than,
So 1, greater than 1.
correct. So here is, and it crosses at 1, mandatory. Remember the exponential function is this. And the log function is this. Good. And then you told me to shift this. Yes. Yes. You mean when I shift this? Yes. This point goes where?
To 7.
To 7. So the vertical asymptote for this function is
0.
not 0, but
1.
why is this?
X equals 0.
Perfect. Where do I move that vertical asymptote?
X equals 7.
6, indeed. So 1, 2, 3, 4, 5, 6.
Is that because it's where, is that what, because it's where it's at?
0 plus 6.
Okay.
And now 1 plus 6.
7.
Perfect.
Do you want us to graph both of these?
Yes, please. We already discussed the range and domain. We're done. The percentage of adult height attained by girls who are x years old can be modeled by f of x equals 62 plus 35 log x minus 4, where x represents the age between 5 and 15, and f of x represents the percentage of her adult height. Use this function to determine approximately what percent of her adult height girls are at age 9. What am I asked to do? I'm asked to, so this is the percent, x is the age, I want to know the percent at age 9.
So what's the origin? 9.
62 plus 35 log 5. That's it. So let's plug it in. Very good. Good. So I have 62 plus 35 log 5. Close the parenthesis. So what is the percentage at age 5? So if they are this tall, this is already 86% of how tall they would be. Maximum, according to the model. Not everyone fits the model, but so approximately 86.5%. Okay? Use properties of logs to expand. Log base 5 of the 7th root of s to the 6th times t over 25. What do we need to do first? Yes, awesome. What the radical means is a power. What power is the 7th root? Okay, power 7 cannot be the 7th root, right? So obviously 2 to the 7th power can never equal the 7th root of 2. This is so tiny that I can't even imagine, right? 1 point blah, blah, blah. And this is huge. Not huge, but... So, what power is the 7th root? Say it again. 1/7. So this is 1/7 in front, log base 5 of s to the 6th times t over 25. So let's go back and refresh our memory. The cube root of x is x to 1/3. The square root of x is x to 1/2. The 7th root of x is x to 1/7. The 7th root of x to the 5th is x to 5/7. So every time you see a radical, the index of the radical is the denominator of the power. So the power has to be a fraction, and the index must be the denominator. So if that entire expression has power 1/7, I have to bring it in front. Now, here's what I have to do, and I recommend this. I see 3 factors. I see s to the 6th, I see t, and I see 25. At this point, I should think in those terms. If I have any number or any number of factors at the top, they will all have plus in front of the log. Any number of factors coming from the denominator will have automatically negative in front of the log. And then you bypass at least 2 steps, if you remember that. If not, it will be a little bit longer. So then I have log base 5 of s to the 6th plus log base 5 of t minus log base 5 of 25. Any questions? Any questions? I'm just putting in attendance so I don't forget. Okay, very good. So now, let's see if we can simplify this. Log base 5 of 25. Now I have no clue, but I know that this can be replaced by an exponential equation. Base, always start with the base, counterclockwise. Base raised, not times. Base raised to this power is this. So what could this be? 2 indeed. So, and I bring the power in front. And I distribute 1 over 7. So final answer, 6 over 7 log base 5 of s plus 1 over 7 log base 5 of t minus 2 over 7. Remember, 1 over 7 has to be distributed to all 3 terms. Any questions? Any questions? Is this okay? The other one is asking us to condense. So how will you condense log 4x minus 3 plus 3 minus log x? What would you say? And we just talked about it a second ago. In the reverse order. If it's a difference of logs, what do I conclude? Yes, the quotient rule, very good. So this will be log, apply to, very good, that's it. Not log, just 1. So log of the top over the bottom is log of the top minus log of the bottom. Any questions? Okay, any questions? Okay, so then we have 9 raised to x plus 4 equals 81 raised to x minus 2. Is this an equation? Yes, it is. It has the equal symbol. It has left-hand side. It has right-hand side, of course. Very good. Okay, so what do? What is the idea?
The base is the same.
Exactly. If I can make the basis the same, I don't need to apply log. Is it wrong to apply log? No. But if I can make both sides with the same base, why not? I'm not a fan of non-prime numbers, but in this case it will work. I can keep 9 to x plus 4 as long as the other side is
2. 9.
yes, 9 squared. Very good. The left-hand side is 9 raised to x plus 4. The right-hand side is 9 raised to, and I have to remember what to do the exponents now. Yes, very good. Awesome. That's all I needed.
Couldn't you just like
Yes?
put parentheses around x minus 2 and then put the 2 on the outside of the parentheses?
But you are raising 9 squared to x minus 2. You're not raising 2 to x minus 2.
Okay.
But yes, eventually you will have to multiply those. I agree with that.
Okay.
Completely agree. Okay. So I have to write 2x minus 4. You can put parentheses if you want or not. So now, remember, we don't cancel, we don't simplify, we say this. 2 numbers are equal and they have the same base. What has to happen? I'm not canceling, I'm not simplifying, none of that. I'm saying 2 numbers are equal and they have the same base. What must happen for the equation to be true? Exactly. X plus 4 must equal to x minus 4. There is no other way. If the exponents are not the same, the numbers will never be the same. So I move 2x and I get negative x, and I move 4 and I get negative 8, so x equals 8. So is that clear how we think? Two numbers are equal and they have the same base. The exponents must be the same. This exponent cannot be 10 and this one negative 5. You understand? 9 to the 10th will not equal 9 to negative 5. So if these two numbers are equal and it happens that they have the same base, these two exponents must be the same. Otherwise, it will not work. Okay, perfect. Now the next equation requires an additional step. E to 2x minus 3 minus 7 equals 1, 2, 1, 2, 6. What is the first step here? Mandatory step, without which I can proceed. Very good. So e to 2x minus 3 equals 1, 2, 1, 3, 3. Correct me if I'm wrong. Now I have no escape because e and whatever that number is can never be presented with the same base. So now I have to use something else, another mechanism that helps us solve for x. What is that mechanism? And the answer is the inverse function. What is the inverse function of e to the x? Look in the calculator. It's on the same key. What is the inverse function of e to the x? ln indeed. That's why they're on the same key. ln and e to the x are inverses of each other. Now I use the property that allows me to bring the power down. 2x minus 3. How much is natural log e? Because I should write times natural log e in parentheses times natural log e. Exactly, that's why we don't write it. Natural log e is 1. Equals natural log 1, 2, 1, 3, 3. Remember, this is a number. Fancy, but just a simple number. I'm solving for x. What do I need to do? Add 3 and then the 2. That's it. So x equals 3 plus natural log 1, 2, 1, 3, 3 divided by 2. And that's your answer. Now solve the log equation. Log base 4 of x plus 6 plus log base 4 of x plus 3 equals 1.
Would that be the answer for the first other column?
Yeah.
Would that be the answer for both of the...
Yeah, if you want the approximation, they will just determine the approximation.
Okay.
Do you want me to put it in the calculator?
Oh, I see what you're saying.
Do you want me to put...
Do we have to do that? Do you want us to do that?
Yes, especially if you want to go back and check.
Yeah.
So,
Yeah.
yeah, just remember to put parentheses around the top.
Okay.
So this is parentheses 3 plus natural log. What is it? 1, 2, 1, 3, 3. Close the parenthesis. Close the parenthesis for the top again and divide by 2. See the parentheses for the numerator and see the parentheses for inside log, and now enter. So 6.2
Okay.
approximately.
Thank you.
Thank you. Okay. So now this is a log equation. Log is not a friendly function. What does that mean? It means that I have to state the domain for this, and I have to state the domain for this, and find the common domain. Or you can say, no, I don't like this, but I promise I'm going to do what? Go back and check. Thank you, Kayla. It's either one, either or. I prefer the domain because, as I mentioned many times before, I want my students to remember that log is applied to a positive quantity only, not even 0. So then what do I have to write about x plus 6? Thank you. And what do I have to write about x plus 3? That's it. So now I will solve the first one, which means x greater than -6. I will solve the second one, which means greater than -3. And from here, I have to find the common domain. I have to determine where they both exist at the same time. Where they both exist at the same time. So you can graph it, but here's the idea. From -6 to infinity, from -3 to infinity. Where do they overlap? From -3 to infinity. But you can graph it if you want. So in other words, when I'm done and I solve and I get x equals -15, what will you say? No solutions. If I get x equals 5, what will you say? That's it. Good. So now we want to condense. We want to condense this side, and then the right-hand side is 1. How do I condense the sum of two logs in the same base, with the same base? Okay, let me refresh your memory. So log applied to a product is the sum of logs. The sum of logs is log applied to a product. So what do we write? So one more time. This is this. This is this. Say it again. This is this. This is this. I want to write this.
So the x squared plus 3x, do we do it that way?
So first I need the log. First I need a log. Log base 4. And then I have to multiply them, correct. But let's write them first without multiplying them for everyone to see. And yes. Is this clear? So log base 4 of a product of two quantities is log base of the first 4 of the first one plus log base 4 of the second one. Okay, good. So now I don't know how to solve this, but I know that it can be changed into an exponential equation. Now the exponential equation is forward to the first equals all this, which is x plus 6 times x plus 3. I'm not going to multiply it here only because I ran out of room, like always. Okay, so then this is x squared plus 3x plus 6x plus 18. Okay, so the most important concept in this chapter 4 is log base a of x equals y is equivalent to a raised to y equals x. This is the most important concept, meaning a log equation can be replaced by an exponential one, an exponential equation can be replaced by a log one. So please don't forget this concept. So as a result of this, I have to write 4 raised to the first power equals this quantity. 4 raised to the first power equals this. Is this okay? So then, yes, I have to subtract 4, and then I distribute it, and I got this. And now the equation, indeed, it's quadratic, so x squared plus 9x plus 14 equals 0. It's quadratic. We have 4 different methods, but I'm really hoping that one of them works. Which one? Yes, I'm hoping that it's not going to take too long. And then I get Very good. X plus 2, x plus 7. So then we get x equals -2 and x equals -7. And I'll say, wait a minute. Why wait a minute?
Because they don't equal numbers.
Because I have the common domain,
Yeah.
and only one of them is in the common domain. The other one makes no sense. I will say yes, and I will say absolutely not.
So it would be -2.
Any questions? Any questions? Is this okay so far? Okay. Then we have A, should be A of t, but I don't know why they don't put that. The model is ending on time. 0.02 t. Describes the population of a country in millions t years after 2003. So 2003 represents t equals. Perfect, very much. Thank you very much. Use the model to determine when the population will be 23 million. When will the population be 23 million? When will the population be 23 million? What are we asked to do? Okay, let's read the problem one more time. The exponential model A of t equals blah, blah, blah describes the population A of a country in millions t years after 2003. Use the model to determine when the population of the country will be 23 million.
So you plug in
Yes?
3 for A.
Of course. 23 equals 13.4 e to 0.02 t. Good. What type of equation is it? So, and how do I solve it?
By 13.4.
Of course, clean it up. So it's exponential. Awesome. And now my only chance to solve this is by
Would you put ln?
apply ln, apply the inverse function to both sides, indeed. So this is natural log 23 divided by 13.4 equals 0.02 t, because log is the only function that allows us to bring the power in front as a factor. But I should write times natural log e. I don't want to. Why? Exactly, because it equals 1. Awesome. So then t equals natural log of 23 over 13.4 over 0.02. And we will know how many years since which year? The population will become from 13.4 to 23. So all I have to do is just put in natural log, and 23 divided by 13.4, close the parenthesis, and divide by, since the denominator is just one number, it's okay if you omit parentheses in the denominator for now. So 27 years. So if t is approximately 27 years, what year is that? Very good, awesome. The logistic growth function, which is f of t, 104,000 divided by 1 plus 5,400 e to negative t. I'm sure you remember this function from class. Describes a number of people, f of t, who have become ill with the flu, t weeks. So t is in weeks. After its initial outbreak in a particular community. How many people became ill with the flu when the epidemic began? Number 2, how many people were ill by the end of the 4th week? And what is the limiting size of the population that becomes ill? It's really, we're not asked to do anything to the function other than plug in. What am I going to plug in?
1, 2, 0.
Yes, I have to find f of 0, and then
And then 4.
f of 4, and then many more values higher and higher and higher. 40 weeks, 50 weeks, 10 weeks, 100 weeks, and so on and so forth. So that's all we need to do, but we have to be very careful how we plug it in. So in y equals clear, whatever, and the numerator is only one number, which is okay. That doesn't need parentheses. But when you put the denominator, if you do not put parentheses, you will not get the correct answer. 5,400 times e right here. In parentheses, please. It may work without. I don't recommend it. Always put the power in parentheses. And then don't forget to close the parenthesis for the denominator. Are we okay with this? I have to plug in 0, 4, and then increase, 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 increase to see what happens for the limiting size. So second and table, 0, 4, 50 weeks, 60 weeks, 80 weeks, and it's very clear where it's going. How much is f of 0? Initially, how many people got sick? After 4 weeks. And limiting size of the population, assuming there are no visitors, because if that changes, if visitors come in, they may get sick too. Limiting size is 104,000 people. Good. Next page. The figure on the right shows the graphs of the cost and revenue functions for a company that manufactures and sells small radios. How many radios must be produced for the break-even? Break-even means when the revenue is 0. I'm sorry, when the profit is 0, when revenue equals costs. So cost is 18,750 plus 19x, and revenue is 49x. Oh, sorry. So the break-even happens when the revenue and the costs are the same. What do I have to write? Anyone? Revenue and costs are the same.